Today we will discuss about the schemas. Okay. So a schema is an outline of the entire data model, which shows how different data sets are connected and how the different attributes of each data set are used for the database design. Schemas are nothing; they are just the database. Okay. So basically, there are two types of schema design. The first one is star schema, and the second one is snowflake schema. Okay. Star schema is a type of schema design that have only one fact table connected to multiple dimension table. Let me show you the diagram. So you can see the diagram here. Here is just a single fact table which is directly connected to the different dimension table. So this is the design of star schema. This is the design of star database. Okay.
Yes, sir.
Now, yeah, there are some advantages also of using star schema are as follows. First one is easy to understand. Why? Because you can see there is just a single fact table which is directly connected to the dimension tables and easy to implement as the design, which is very simple, just a single and the multiple dimension table, and it is efficient in terms of querying because a maximum of only one join is required. So as we can see, all the tables are directly connected, so we just need to use single join to fetch the table to fetch the data from the two tables. So this is about star schema design. Now let's come to the snowflake schema. So snowflake schema is called so because the dimension table surrounding the fact table can branch off into more dimension table. Now let me show you the diagram. So here you can see there is a one fact table which is connected to other dimension table, and those dimension table are further connected to other dimension table. So this is the design of snowflake schema. So here you can see, like when we have the large data, okay, so snowflake schema are particularly useful when it becomes difficult to manage the size of dimensional table. When we have the large data, then we use snowflake schema because they are efficient in terms of data storage. Okay, if we have too much dimension table, then we can use this type of schema design, that is snowflake schema. Again, I am repeating. The first one is star schema, in which there is only one fact table which is directly connected to other dimension table. It is easy to understand, easy to implement, and we can easily apply join between two tables because they are directly connected to each other. But in case of snowflake schema, we use this schema whenever we have the large data set, whenever we have the large data. So this is efficient in terms of data storage. It takes multiple dimension table. That's why we need multiple join to get the data from different tables. So this is all about these two type of schema, star and snowflake schema. Is this clear?
Yes, sir.
Okay. Now let's come to the two types of databases. The first one is OLAP and OLTP. Okay. Basically, what is OLTP? So OLTP stands for Online Transactional Processing System. So it deals with day-to-day operations data. Okay, for example, if there is a DMart store, so the daily transaction of the data, daily transaction of the store will come under OLTP database. Or let's take the example of bank. So daily deposits, daily withdrawals, all the daily activities. Okay, these data will goes to the OLTP database. So it is used to perform business transaction. It is used for day-to-day operations. And we can say this is mainly for transactional data. So here we do not require any analysis to perform over this data because this deal with the current data only. Now read data warehouse, that is also known as OLAP. So OLAP is online analytical processing system. As we earlier also discussed about the data warehouse, so data warehouse is also called OLAP. So basically it is a historical data over which we can perform the analysis to generate insights for decision making. So it it contain ETL process, extract, transform, and load. Okay, we can use BI tool over this data to analyze like Tableau, Power BI, Python, okay, and other analytics tool as well. So OLAP deals with the historical data. OLTP deals with current data. Okay,
Correct. Right.
we cannot perform analysis using current data because we cannot answer like question that how much the revenue for last last quarter. Okay, why? Because this is the current data, we cannot answer the question. But using data warehouse, using OLAP, we can answer the question like the revenue for last quarter, the profit, the loss for last quarter, which product sells more or less in the last quarter, in the last year, in the last 5 years. Okay, so using OLAP data warehouse, we can perform the analysis, we can make the decisions, okay, we can generate the insights. Got it?
Yes, sir.
Okay, great. Now, the next is constraint. Now, what are the constraints? So basically, a constraint are the rule which is used to restrict the values that can be stored in the columns of a database. So this ensure data integrity, which is nothing but the accuracy and consistency of the data stored in the database. Let's take an example, okay, to understand what are the constraints actually. So let's put yourself in the place of a data analyst at Uber company. Do you know about the Uber company?
Yes, sir.
Yeah, it is a bike riding or car riding company. Okay,
Yeah.
so let's take a data warehouse at Uber has several tables, which like several table which record several details such as details of the rider, the driver detail, the vehicle detail, and the transaction detail. Okay, so it the warehouse of Uber will contain all these type of features in it. Okay, driver detail, and the rider detail, and the vehicle, and the transaction detail. Okay, so each such table has several related attributes which describe it in detail. Consider the rider table. Let's take the rider table, and you go through the values entered in a column that contain fare for each ride. Okay, there is a column in rider table which contain the fare for each ride. Okay, and it would be right for you to expect that the fare can the maximum value of like 1000, 2000. Okay, but if you see there is a value in the column like 5 crore. Okay, so could you tell me like this is the correct value or it will raise some concern? If I say there is a column in which there is a fair value as 5 crore, so this value is correct or wrong? Just
Wrong.
tell. Yeah, definitely. So this type of error, this type of irregularities, we need to restrict to be entered into our database. So we use constraint for this purpose. Got
Yeah.
it? So basically, this
Yes,
is
sir.
an outlier and needs to be replaced with the right value. Got it?
Yes, sir.
Yeah. So constraint, there are three types of constraint. The first one is entity constraint, and then referential constraint, and then semantic constraint. First of all, let's discuss this entity constraint. So in entity constraint, there is unique constraint, null constraint, not null constraint, primary key constraint. Now discuss. So unique constraint only take unique values in it. Okay. Let's suppose uh, I am imposing unique constraint over a column. So the column will only accept unique value. It will not take the duplicate value in it. Okay. So it is restricting the duplicate value to be entered into the column. Clear?
Yes, sir.
Now null constraint. So it determines the column that can have null value. So basically there are two types of constraint, null and not null constraint. So constraint specify that it contains null value, and not null constraint specifies that the column cannot contain null value. Okay.
Yes, sir.
Now primary key. So a primary key, we can have a single primary key in one table, okay, and it uniquely identify each row in a table. What is the role of primary key? It will uniquely identify each row in a table. Here, it will primary
Yes.
key constraint always enforce both unique constraint and not null constraint. Now, what does it mean? Primary key constraint will take unique value also and not null value also. Now, there is a question, what is the difference between unique key and primary key? Although unique key also take unique value and primary key column also take unique value. Now, what is the difference? You got it?
Yes, sir.
So you just answer me. What is the difference between unique and primary key?
Uh, Primary key can be null.
No, 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 no. See,
Mm.
unique constraint can take unique value only. Okay, it will not take duplicate value. But unique constraint can take null value as well. Got it? But primary key
Yes.
constraint will take unique value and not null. It means it will not take null values. But unique
Can
constraint,
primary key contain duplicate values?
no, it will not. I'm saying that it will take only unique value. Now, what does it mean? That it does not take the
Okay.
duplicate one. If it is taking only unique value, then it cannot take the duplicate value. Na?
Yes, sir.
So the major difference between unique and primary key is that unique constraint can take unique value and null value also. But primary key constraint will take unique value, but it will not take null value. Clear?
Yes, sir. Yes.
Now there is one more key that is called composite primary key. Now, what is composite primary key? Let's suppose we have a table, but we are not able to define any column as a primary key. Why? Because there are columns which take null value also. They are taking duplicate value also. So we are not able to specify the primary key. Okay. So in this type of scenario, we create a composite primary key. So we can create by combining two or more column in a table that can be used to uniquely identify each row in the table when the column are combined. So using more than one column, we can create primary key, and that key known as composite primary. Is it clear?
Yes, sir.
Yeah. Now there are candidate key also, alternate key also. So like what is candidate key? Basically, it is a single key or a group of key that can uniquely identify each row in a table. Basically, they are the candidate key. We can define any column as a primary key from these candidate. Okay, these are eligible
Yes.
for becoming primary key. That's why we are calling them as candidate key. Okay.
Yes, sir.
Yeah. And what are the alternate key? To set of candidate key other than primary key. Okay. Let's suppose we have four column, and out of four we have three column which are candidate key. Three column are eligible to become primary key. But as per the condition, we can only specify a single column as a primary key. Okay. So when
Yes,
we
sir.
select the primary key, one column for one column, the other two column are called as alternate key column. Is it clear?
Yes, sir. Yes, sir.
Okay. Now, the second type of constraint is referential constraint. So these are used to restrict the values that are taken by a column in one table based on the values that exist in another table. According to this rule, the value that appear as a foreign key in a table is valid only if it is appear as a primary key in the table to which it refers. Now, what does it mean? See, below you can see the two tables, employee and department. Okay.
Yes.
Now, the department table having department ID is the primary key in this table. I'm talking about department table and department ID of this table. So this is the primary
Yes.
key. So what does referential constraint say? It says the value taken by a table in primary key. Okay. See, let me repeat once again. The value taken by foreign key table is only valid if it is present in primary key table. Okay, so let's take example D01. If it is present in department ID, then only it will present in employee table of department ID, because in employee table, department ID is the foreign key column. Okay, so what does this
Yes.
mean? If a primary key is entered, if a value is entered in the primary key column, then only we can enter the value in foreign key column. So both values are related. If the value is not present in primary key column, we cannot enter it in foreign key column.
Yes, sir.
Is this clear? If you have any doubt, do let me know. I will repeat it once again. But make sure everything is clear to you.
Sir, what is a foreign key? Why do we use that?
Yeah, see. Basically, we use foreign key to define the relationship between two tables. Like earlier also, yesterday we discussed about the types of relationship. Na? So those
Yes, sir.
relationships can be defined with the help of primary and foreign key. See, we have a department table. There is a column department ID. I'm defining this department ID is a primary key column. Now, this
Yes.
department ID column is also present in employee table. But here, department ID is not the primary key. Okay, because we already defined it
Yes.
as a primary key in department table.
Mm.
Okay, so
Yes.
here in employee table, department ID is the foreign key column. And on the basis of these two column, department ID in employee and department table, we are creating the relationship between these two tables using foreign key and primary key.
Yes, sir.
Today we also discussed the relationship one to one to many to one, many to many. So those relationship can be defined with the help of primary and foreign key column.
Yes.
Is it clear now?
Sir, can a foreign key be not unique or not null?
Yeah, this is a good question. So foreign key column can take duplicate values. Okay, but primary
Yeah.
key column cannot take duplicate value. It will take only unique. But foreign key column can take duplicate value. Okay,
Yes, sir.
clear.
Yes, sir.
So let's read the third point. A given table has only one primary key. As I earlier told you, a table can have only a single primary key, but a table can have multiple foreign key. It means in a single table, we can define multiple foreign keys. Okay, but only single primary key can be defined for a one table. So before you assign a column as a foreign key, you need to ensure that the primary key column of the table that it refers to is present and it does not have null or duplicate value. So it means before defining the foreign key column, it is mandatory to define the primary key column to which it is referred. Clear?
Yes, sir.
Okay. Now the last one, the last type of constraint is semantic constraint. So semantic constraint impose additional restrictions on the values in a column using semantic constraint ensure that we do not get incorrect data for any row in the database. See, all types of constraint are used to restrict the irregular value, okay, used for
Yes.
entering irrelevant, incorrect data into the database. Okay, so the role of semantic consent is to restrict incorrect data. So let's read this example. A row with an Indian phone number not having 10 digits after the country code would not be allowed to enter the database. So we know an Indian number has only 10 digits. Okay, after the country code, if we got a number which has more than 10 digits, so that will not be allowed to enter our database. Okay, because we are
Yes, sir.
using semantic constraint. Clear?
Yes, sir.
Yeah. So yeah, so this PPT is now completed. Let me summarize the whole PPT once again. Okay. So in this PPT, we discuss about the relational database management, which is the system which store your data while preserving the relationship within the data. It is a management system that store data in the form of table, in the form of column, in the form of rows, and each table is connected to other table in the database. Now we had discussed about the warehouse and the data warehouse. So the concept of data warehouse is similar to the normal warehouse. So data warehouse is used for storing the data, and it is used to store data such that its retrieval and management becomes easy. We had discussed about the characteristics of data warehouse. So it is subject oriented, built for a specific purpose, integrated, collected from multiple sources into one form, non-volatile, data does not change over time, time variant, capable of capturing information over the time. Then what is this diagram says? Please tell what this diagram says.
ETL, about ETL.
Exactly. It is the ETL. Means the journey of a data in an organization. So it says the complete journey of a data in an organization. First of all, we need to extract it from multiple sources. Then we need to transform the data into the correct format. Then load the data into the data warehouse. And after that, we can analyze the data using analytical tool. ETL again, extract, transform, load. Then the dimensional model. So basically it is a database structure technique and it is used to optimize the data for the fast retrieval of data. And it has two entities, fact and dimension. So what are fact? Fact are the numerical data and dimension are the metadata. Okay. So as
Yes.
I told you, both fact and dimension are equally important for generating actionable insight from a data set. You need both fact and dimension for performing better analysis. Now, ERD. So, ERD is the entity relationship diagram, which is a representation of the tables in a database. It gives you the idea how different tables are connected, what columns they are containing, what type of constraint they are imposing in the column, what type of relationship are there between two tables. Okay, so it will give you the whole idea about your database in very less time. Now, these are the notation, these are the cardinalities, one, many, one and only one, zero or one or many, zero or many. Now, the types of relationship. So I told you these type of relationship created with the help of primary and foreign key. Okay, yeah.
Yes, sir.
So there is one-to-one relationship, then one to many, many to one, and then many to many. Okay, so there are four type of relationship exist between two tables. Now the schema. So schema is just a outline of the entire data model, which shows how different data sets are connected and how the different attributes of each data sets are used for database design. So basically, there are two types of schema design. The first one is the star schema, which contain a single fact table, which is directly connected to the multiple dimension table. And this type of schema design helpful in it is helpful in fetching the data easily because it will need only one join to extract the data. Snowflake schema, so it has the advantage that if we have the large data, we can store using this database design in which there is one fact table connected to multiple dimension table, and those dimension table further branch off into other dimension table. Then the two types of database. First one is transactional database. Second one is data warehouse. So transactional database is also known as OLTP. Data warehouse is known as OLAP. Transactional database, the OLTP. OLTP deals with the current data. Okay, it will deal with the day-to-day transactional data. But OLAP deals with the historical data. It has data of last 10 year, last 15 year, last 20 year. Okay, so using OLTP, we cannot perform analysis, but using OLAP, we can perform analysis. Okay.
Yes, sir.
Now the constraint. So these are just the rule which help us, which help the columns of a database to stop the incorrect value to be entered into int. Okay.
Yes, sir.
Now there are three types of constraint: entity constraint, referential constraint, and semantic constraint. So as I told, in entity constraint, there is unique, null, not null, primary key constraint. Okay. And referential constraint, like it says we can enter a value in foreign key column only if it is entered in primary key column. Got it?
Yes, sir.
Okay. Now semantic constraint, so it helps, it's again stops the incorrect data to be entered into our data warehouse. So this is all about this PPT. This is the first module of our SQL. Okay.
Yes, sir.